Good morning and welcome back to another episode here from the Off-Grid Garage in, sunny hot Australia. I tell you, I'm already losing some oil. Well, I'm doing a little experiment here with the fan and the cabinet. I haven't experienced any overheating so far, but I was just wondering, I measured the solar charge controllers at 50 degrees before, and I know they are throttling down at some stage, and this is just an experiment, but we are still getting the 3 kilowatt output. So this is not dependent on the solar charge controllers, but more on the solar panels, which are in the brightest and hottest sun ever. Man, glad I went onto the roof yesterday when we had cloudy weather and a little bit of drizzle, a little bit of rain showers coming through from time to time, and it was only like 22, 24 degrees. And I finished up all my cabling, so all the cables are now in conduit under the solar panels with stainless steel cable ties tucked away as it should be. I still need to improve the earthing up there, drill through and put a bolt in there and put all these earth cables into conduit as well, so it's all nice, tidy. But I'm certainly not going up on the roof today. It is far too... So I think because we have all the gear here to build up our battery shelf now, I thought we are starting here with changing the setup of our cabinet here a little bit, because I want to move the inverter out of this cabinet here. And I've got these larger aluminium sheets already here. This is my template for the inverter. I really want to mount the inverter here on the right hand side of the cabinet, so it sits outside. It gets a bit more air cooling because it gets quite warm in this cabinet even with the fans inside. And I also want to connect more circuits to the 240 volt side, and well, we have only space for these 3 circuit breakers in there in this little switchboard situation inside the cabinet. This was all fine until now, but well, as I said, I want to expand the circuits here, so I need more space anyway. And this gets all a little bit crammed inside there. The second reason I want to do this is I need more space for solar charge controllers inside the cabinet for future expansions of the solar system here on the Off-Grid Garage. We still got the carport and the other shed here as well, which I would like to connect in the future setup then. So at least 4 charge controllers in there and even bigger charge controllers. Yeah, and then finally I want to move the battery shelf here in its final location in this gap here. This one goes, but this is step number 3 or so. Okay, let's start with the inverter first. And as you can see, I've already put 2 more posts in here, but this was for a horizontal setup of these aluminium plates, but I want to go vertical now. So I will have the inverter up there and a switchboard situation down here then for my electrical 240 volt outputs, different circuits, RCDs, breakers, and all this kind of stuff goes underneath. So I need to move this one here a little bit further that way. So that's the first thing I'm going to do right now. Yeah, the charge controllers are now at 40 degrees, 42 this one, and the output is still around 3 kilowatts. So definitely not a problem with the solar charge controllers. Okay, so step 1 is done. Mounting this aluminium sheet here. So this is how it looks like then. This is the new home for the inverter and switchboard. And I've put this on hinges, so I can actually get behind it easily if I have to do some cabling or maintenance or any upgrades for other inverters or so. I can still get this one off the wall a little bit here safely and work behind it with the cables. So next step would be to move this post here somewhere here in the middle, so that this aluminium sheet is actually halfway this post, and then on the other side there will be the other aluminium sheet here, which is a bit smaller, but this is all the space I have here in the garage. And then I should have enough space for 2 larger inverters up to 10 kilowatts each. later on down the track when we can connect the house. But for now we move this one there and see how we go. Of course. So we have now done all the preparation work and the inverter can move. I guess this is the next step, right? So down here the switchboard and up there the inverter. That's the plan. So, the plan is to have 4 circuits in this switchboard here. One of the RCDs, MCBs, will go to the pool. This is our pool circuit, which we will disconnect from the switchboard down here and then feed it in here and connect it to the off-grid system. Funnily enough, this circuit doesn't have an RCD at the moment. There's no earth leakage protection at all on the pool circuit. Just a fuse, that's it. So this needs to change. And the second circuit with an RCD as well goes to the second vehicle charger. So usually I plug in over here and charge from the mains, but I have installed already a second socket here, and I've got another EVSE, which is the electric vehicle supply equipment, and this will go over here. And there will be an isolator next to it here on this board, and then we connect this one to our off-grid system. So I can charge the car mainly from the off-grid system here, but if I don't have enough power or something, I just plug in over there to the mains and charge there. Probably for 3-4 months, maybe over winter time, when we have too much shading here on the garage. But we will see. With the more solar on the roof then later on, who knows, maybe we can reduce this to 2 months. And then we've got these 2 circuits here which are in the cabinet at the moment. One is for the lights and the other one is for supplying power to the garage here, irrigation pump, workbench, all power points in here. Yeah, and this all will go into this switchboard here, and then we've got spares over here as well, because as I said before, we may upgrade this off-grid inverter here at some stage. And then we have got more power. We can potentially put more circuits here on this situation. I'm not sure yet. I don't know yet. This is just speculation, wishful thinking. So what I will do now is I will turn off the inverter, so we don't have power here on the circuit breaker anymore. Then I can take off all the 240 volt lines here, disconnect all this. This is our supply for the garage and lighting here. And then we can connect this one to the new switchboard already before we actually move the inverter. That sounds like a reasonable plan to minimize downtime. Eco. Have to hold it. Yeah, that looks off now. So there should be no power on here anymore. Coming from the inverter, 000 volts. There's nothing anymore. 0. Okay, I will disconnect these ones first anyway here, then the whole rest is dead. And the earth, alright, we are totally isolated now. Even if the inverter turns on again, there's nothing on the circuits anymore. Nothing at all. Good morning to day number 2 of our changeover here. After lunch, I felt so tired. I said, nah, it's not worth going back into the garage again and do all this inverter stuff. tomorrow is another day. Well, that's today. So we've got plenty of time today to move the inverter out of this cabinet there. See, I've got the lights actually set up for last night and had the Blue Eddy here to give me some light and everything. But yeah, it just didn't happen. Okay, so first thing I want to do is now take the DC cables off the inverter. And for this to happen, we need to turn off the solar. West roof. Okay, charger is off. Same for the east roof. Charger off. Okay, so there's no charge coming in. Minus 3.5 amps, which is my DC supply here. Alright, so I'm always turning off the solar charge controllers first before I flick the actual circuit breaker. So this prevents a big spark in here. I mean, we've got like 25-30 amps coming in at the moment here. So if I do this now, there's no solar input anymore. There's positive, negative isolated. And now we can do the same here with the solar charge controllers, so they are completely shut off. And we have to turn off the Raspberry. Power off. Apparently power off works as well. System is going down for system hold now. So power off is the easier. Well, a lot of people have sent me scripts and hints and tips and everything, and well, I think the whole Raspberry situation is another project, you know, by itself. There's so much to learn, so much to test, so much to do, what you can do with a Raspberry. So yeah, I haven't done any of that yet. I'm still solely focusing on the inverter stuff and cabling and all this kind of stuff, not on the programming and automatization. There's no power on it anymore. There we go. I just need to take out this bridge and then we can turn on the solar charge controllers again to keep charging the battery. 2 volts. There might be still a capacitor. Yeah, voltage is going down 1.9, 1.8, 0.5 volts. So there's no power anywhere anymore at all. Nothing. Zero. Yeah, and this one here is the 9/16 of an inch socket here we need for the bus bar. Because this is made in America, and the normal matrix sockets don't fit. So 14 millimeters up here, but 9/16 goes up here. Okay, and here comes our first bridge. Positive, gone. And negative. Of course I will keep them here for, I don't know, maybe a future project or something. It's always handy to have these cable connections here. There's a 35 millimeter cable, you know, with 8 millimeter. Oh, there's a... Okay, now we can take out this train relief for the 240 volt. And we also have to take off the power supply for our fan controller here, which is being controlled by the inverter as well. So there's a relay contact here which closes the circuit and turns on the fans. So this won't work anymore either. I have to come up with another idea how to control the temperature inside the cabinet here. Of course you can buy these electronics on AliExpress or something. They come with 2 or 3 different temperature sensors and they've got a relay contact. So that would be an easy way, but I thought maybe there's another way and we can use the Raspberry as well to control the temperature inside and even display them somewhere, something later down the track when we have the Node RED. So I'm holding off on doing anything with the temperature control at the moment. I don't want to end up with all these electronics inside, you know, these different types of electronics everywhere to control single elements. On one hand, it is good if you have several electronics or several control systems to control your whole system then. If one fails, only this one part fails. But if you have everything integrated into one system like the Raspberry, and the Raspberry fails, everything will stop working. So I'm not really sure which way I want to go. It's good to have everything integrated into one system, but then from a fail-safe perspective, it's better if you have multiple systems. So yeah, not sure yet what to do. Maybe someone can make some recommendations how to proceed with that. So, and here you have to push on these orange parts here to release the cable. Here comes the positive. Yeah, and this is where the relay used to sit in between to turn on our fans then. Okay, and then we've got the VE direct communication cable coming out. And the last thing we have to disconnect is the ground or earth. And then the inverter is free to come out. So, and the very last thing we need to do is get rid of these two screws here. And then we can just lift up the whole inverter, because it's sitting on this bracket. At the top there's like a hook bracket, and the inverter sits onto it. So if we take these ones out, we should be able to lift it up then and take it out. Oh yeah, it is heavy. Got it. And here's our mounting bracket. And remember, we had this plate off at the beginning here and had some nuts behind it. So I hope when I undo these screws here, they're just falling down. And if I lift this one a little bit up here, they fall out. Otherwise I just leave them behind there. It doesn't really matter. They don't do any harm. I don't want to take out this whole plate again. This is a lot of work. Not yet. That's a good start. Unless these bloody nuts. Here we go. Okay. Wow, that is. Who tightened this? Yeah, I think the nuts are spinning on the back. But if you twist them fast enough, they should come off eventually. Okay, that's a theory. Oh yeah, here we go. Yep, this was easy. Done. Okay, I'm just taking off the fan controller cables, power supply. I like this bus bar actually here. It's good to have these little screws here on the side where you can have your other DC load connected directly. We put the cover back on, and then we can turn on the solar charge controllers again. Yeah, well, there's nothing connected anymore. We don't need to pre-charge anymore because there's no inverter connected anymore. We can just turn it on. Yeah, the Raspberry is coming on again. And then we turn on the solar charge controllers. Turn on solar back on. Yeah, this east roof, we can see 96 volts coming in. And enable charger. Network total power is 1.5, 1.6 kilowatts already. So that's all good. 2.7. Yay. So this is the 20 millimeter corrugated conduit here, and this fits perfectly into these gaps here where the cables are going in. This is all good for my 240 volt. And for the VE Connect and the earth cable, this is all fine, but not for the DC input cables. This is just not large enough to fit a 35 millimeter cable. I mean, the cable just fits. But I would really like to use the 25 millimeter cable, but this one is a bit tough. I have tried to really push it in, and it works. So, and this is really solid, you know. And then the plan is to, let me show you here. So the plan is to have these conduits then bent like this. So they're going back into the wall just under the connection terminals here of the inverter. If this is our inverter, basically they are coming out of the inverter and then bending down straight away. I drill a hole in here and they go behind the aluminium plate, and then I can wire them up to the switchboard or to other connections here in the system. Well, that's at least the plan. If this all works out, we will see today, soon. Then let's mount this inverter back on the wall. Right, Toby? Excuse me. Okay, I guess here comes the big moment now, and we mount the inverter back on the new location, and hopefully the hinges are strong enough to hold this massive heavy inverter. I think it's about 20 kilos or so. Okay, let's do it and find out. It? Is it already in the bracket? You never know if it's in the bracket already or not, or just on one little edge. I think it's good. Yeah, definitely. And now we are drilling these two holes again here and just tap into the aluminium. This is just to prevent the inverter from coming off if you accidentally push it upwards. So it comes off the bracket, and these two screws will prevent this from happening. Man, imagine the inverter comes off now and falls down and is totally fucking broken and smashed up. Yeah, well, originally I wanted to have the inverter actually on this side here. This was our off-grid installation then, and this would be the on-grid installation, hybrid installation to supply power to the house as well. Well, this project is a little bit postponed at the moment, as you know, so I have decided to move everything over here, because once the battery shelf is in place on this location here, there's very limited access to this area above the shelf. So I'm not sure if this is actually a good solution to put the inverter up there somewhere. I mean, it's maintenance free, you don't touch it at all. You wipe it off from time to time, keep it clean and everything, but there's nothing really to do with it. So I keep this idea for later and see how we go. But then on the other hand, we still have another location here for another inverter. Okay, well, what a work with these holes here. Even it is only 3mm aluminium, it is a lot of work. And very, very cruel to the battery drill as well. It gets super hot. I really wish Victron would have made this one here a little bit longer, so we can have these holes inside this compartment and not on the outside. It's a bit of pain in the ass here with the bending and everything. I mean, originally it was probably designed to have a cable duct or something, like a trunking underneath where the cable goes in. Well, if the cable trunking is wide enough and high enough, it would cover this whole section here. But then again, this compartment double as long, and we can have the holes inside. Here we've got our USB connection extension. This is just a temporary measure as well until the new battery shelf is in place. And then we will connect this properly here with a cable back to the inverter. I read actually in the manual, if you do some maintenance on these devices, you should pull this this is the remote switch to turn it off and on. If you pull this one out, it is basically ensured the device will not turn on. Well, guys, the problem I have now is that the cables are a tiny bit too short. So I cannot really connect them from the top where the inverter used to be connected. I probably have to, I was going over here somewhere, but then I cannot really, we've got only these gaps here where the cables can come out. So I thought it might be easier if I put this on top of the other one, but it doesn't work either. I'm just realizing I probably have to go like this somewhere. Okay, it works like this. So if I put it on the second rod here and then feed it down like this, the cover fits on there again. That's all I can do probably. It's not so much an issue on the other side here, but the positive is just a tiny bit too short. Okay, this is all connected so far. I think we are good to go to press the pre-charge button. Here, where is it? There it is. Okay, shall we try it? Okay, so first thing we want to test is the DC input voltage. 53 volts. Oh, battery is full. And now we're going back on AC and measuring here our output voltage of the inverter, 229. This was active to neutral, active to earth, 229, and neutral to earth, 0. And I'm measuring active against the chassis here. Yeah, 229, neutral against the chassis, 0. Nice. Oh, are you sleeping here? Okay, I just plugged in the vehicle and the charger is green. So that means everything is all right with the earth connection and bonding. So that's always a good sign. Okay, let's charge the car for a moment. Half an hour, 2 hours, and see if the inverter performs. Start charging. Ah, I haven't turned on the solar. Okay, let's do that. Totally forgot about my solar. Yeah, 35 amps. Going into the inverter now. Cool. Yay! 20 watts. 21 watts! That was nice. You know, we are measuring 21 watts all the time. Under random circumstances. Nah, there's nothing. See, we are getting a 1400 watts here from solar still. At 3 p.m. 1700 watts. But still we are now transferring the 1600 watts through these 16mm cables here. There might be some heat building up over time. I'll give this a try right now. Can't believe we've got all these ants inside here, and they're all coming out of the conduit here, which is coming from the roof. This is the conduit going up to the solar panels for earthing. I think I didn't put any silicon in the other side there, because I wanted to feed one more cable through, which I did. And then I forgot to, well, it's what you get. Ants. Nothing. Okay, let's do a little test and turn on the irrigation pump. And this should give us max power here on the inverter. Yep, there's an overload warning now coming. So it must be close to 2600 watts. It must be close to 3 kVA now. Okay, I think this is all good. Just to show you, we've got actually about 25 degrees already outside here. This is what the shelf is. I think we are all good. There we go. Okay guys, I think this is how far we are going today. I'm over it now. This took me all Saturday and all Sunday basically. And it's not so much the actual work which takes that long. It is all this little side work you have to do. You know, you have to drill a hole here, tap, find the right screw for it, put it all in, change the design a little bit, and then stand back, have a look, think about your design again. How do you want to run the cables? Where do you want to run the cables? And all this side work is so much time. It is not funny anymore. Okay guys, the only thing I need to do now is clean up this mess here. I've got shit everywhere here over this shelf. The same here on the table. And I cleaned up the workbench already a bit. There was mess everywhere. Okay, as promised, we will have a very nice cold spat now. And then we will... Holy shit. I've forgotten to put one in. Okay guys, I think I've got a spare one inside the fridge in the house. So we will just fall back to plan B. As always guys, thank you so much for watching. Thanks for all your support here on the channel, for everything you are doing here. It is an amazing journey. And I guess in the next video we can actually transfer the pool circuit from the outside meter box to the off-grid system here and then run the pool pump and some other non-essential loads from the off-grid system, from the battery, from solar directly. So we're taking this completely off the grid and put it here on our circuits. So I'm really looking forward to it. Until the next video guys, stay charged, stay safe, and thank you again for watching. See you then, bye bye.